So, good day everyone. Today I will discuss how to solve these basic integration problems using the integration rules. So the problem is the integrals of 10x raised to negative 3 plus 12x raised to negative 9 plus 4x cubed with respect to x. So first we apply the power rule of integration. So the power rule of integration is used when integrating variables with exponents. The rule says that we add 1 to the exponent, then divide by the new exponent. And it goes like this. So 10x raised to negative 3 plus 1 to the exponent over negative 3 plus 1. Then plus 12x raised to 9 plus 1 to the exponent over negative 9 plus 1 plus 4x cubed plus 1 over 3 plus 1, then plus c. Then integrate each term one by one. So 10x negative 3 plus 1 equals negative 2. So raised to negative 2 over negative 2. Then plus 12x negative 9 plus 1 equals negative 8 over 8. Then plus 4x 3 plus 1 equals 4 over 4 and plus c. So 10 divided by negative 2, so negative 5x raised to negative 2 plus, so 12 over 8x raised to negative 8. So let's just divide it by the common factors, which is the 4. So 12 divided by 4 equals 3 over negative 8 divided by 4 equals negative 2. So x raised to 8 plus 4 divided by 4, so 1. So x raised to 4 plus c equals, so negative 5 x raised to 2, so negative 3 halves, so minus 3 halves, x raised to 8 plus x raised to 4 plus c. So here's the final answer. So another problem is the integral of cube root of x plus 10 times the fifth root of x cubed with respect to x. So first, let's convert the radicals into fractional exponents. So the integrals become x 1 over 3 plus 10x 3 over 5 dx. Then apply the power rule. So x 1/3 plus 1 over 1/3 plus 1 plus 10x 3/5 plus 1 over 3/5 plus 1 plus c. Then x 1/3 plus 1 equals 4/3 over 4/3 plus 10x 3/5 plus 1 equals 8/5 over 8/5, then plus c. And simplify. So x becomes 3/4 x raised to 4/3 plus 50 over 8 x raised to 8/5 plus c. Then we can simplify this. So 3/4 x raised to 4/3 plus using their common factors, the 2, so 50 divided by 2, 25 over 8 divided by 2, 4, 25 over 4 x raised to 8/5 plus c. So here's the final answer. 3/4 x raised to 4/3 plus 25 over 4x raised to 8/5 plus c. So let's solve this. The integral of 7 over 3 x raised to 6 plus 1 over x raised to 10 minus 2 over the cube root of x raised to 4 with respect to x. So first is we write everything using exponents. So the integrals become 7x negative 6 over 3 plus x raised to negative 10 minus 2 over x 4/3 dx. So 7x raised to negative 6 over 3 plus x raised to negative 10 minus 2x negative raised to negative 4/3 dx. So apply the power rule. So 7x raised to negative 6 plus 1 over 3 times 6 plus 1 plus x raised to negative 10 plus 1 over negative 10 plus 1 minus 2x raised to negative 4/3 plus 1 over negative 4/3 plus 1 plus c. Then simplify. So 7x integrate 7x minus raised to negative 5 over 3 times negative 5, or times negative 5 is negative 15 plus x raised to negative 10 plus 1 is x raised to 9, negative 9 over negative 9. Then minus 2x raised to negative 4/3 plus 1 is equal to 1/3, negative 1/3 over negative 1/3 plus c. Then simplify. So 7 over 15, so negative 7 over 15 x raised to negative 5 plus 1 minus 1 over 9x raised to negative 9, and so simplify, so it will become plus 6x raised to 1/3 plus c. So here's the final answer. The final answer is negative 7 over 15x raised to negative 5 minus 1 over 9x raised to negative 9 plus 6x raised to negative 1/3 plus c. So another problem is the integral of x raised to 8 minus 6x raised to 5 plus 4x cubed minus 2 all over x raised to 4 with respect to x. So first is let's divide each term by x raised to 4. So x raised to 8 over x raised to 4 minus 6x raised to 5 divided by or over x raised to 4 plus 4x cubed divided by x raised to 4 minus 2 over x raised to 4 dx. So x raised to 8 divided by x raised to 4 equals x raised to 4 minus 6x raised to 5 divided by x raised to 4. So this would become 6x plus 4x cubed plus divided by x raised to 4. So 4 over x, then 2x raised to negative 4 dx. So use the power rule. So x raised to 4 plus 1, 4 plus 1 equals 5. Then minus 6x, add 1 to the exponent, so 1 plus 1 equals 2 plus this would become just 4 ln of x, then minus 2x raised to negative 4 plus 1, negative 4 plus 1 equals negative 3, then dx plus c. Then 1 over 5x raised to 5 minus 6 divided by 2, 3x squared plus 4 ln of x, then negative 2 divided by negative 3, so plus 2/3 x raised to negative 3 plus c. So the final answer is so 1/5 x raised to 5 minus 3 x squared plus 4 ln of x plus 2/3 x raised to negative 3 plus c. Another problem is the integral of 2 cosine x minus secant x tangent x with respect to x. So in this, use the trigonometric integrals. So the integrals of 2 cosine is sine 2 sine x. Then the integrals of secant is secant, so sec x plus c. So this is the final answer. The 2 sine of x minus secant of x plus c. So another problem is the integral of 6 over cube minus 2 over x with respect to x. So let's just rewrite this using the negative exponent. So the integrals become 6x raised to negative 3. Using the logarithmic rule, so negative 2 ln of x dx. So the first term, let's just apply the power rule. So 6x raised to negative 3 plus 1. Negative 3 plus 1 equals negative 2 minus 2 ln x plus c. Then 6 divided by negative 2, so negative 3x over, raised to the power of negative 2 minus 2 ln of x plus c. And this is the final answer. The negative 3x raised to the power of 2 minus 2 ln of x plus c. So let's solve for the integral of 4w plus 3 all over 4w squared plus 6w minus 1 with respect to w. So we use substitution. So let u 4w squared plus 6w minus 1. Then we find the derivative of u. So the u equals 4 is 4 times 2 is 8w, then plus 6, and our dw equals du over 8w plus 6. And so the integral of 4w plus 3 over u, and du over 8w plus 6. So next process is 4w plus 3 over 8w plus 6, then 1w over w and du. So let's factor out the denominator. So 4w plus 3 over 2 times 4w plus 3 1 u du. So it will be 1/2, and the integral of 1 over u dw. So equals, so 1/2 1, so ln of u plus c, because we integrate them. So 1/2 ln, and our u is the 4w, so 4w squared plus 6w minus 1 plus c. And this is our final answer. 1/2 ln of 4w squared plus 6w minus 1 plus c. So another problem is the integral of secant of 1 minus z tan of 1 minus z with respect to z. So we use the substitution. So let u be the 1 minus z, and the derivative of u, differentiate both sides. So negative 1 dz or negative dz, and our dw equals du over negative dz. So So the integral of secant u tan u negative du. So take out the negative, so negative, and the integral of secant u tan u of u du. So we know that the integrals of secant is secant. So negative secant of u plus c. So negative secant, and substitute the u, 1 minus z, 1 minus z plus c, and this is the final answer. So negative secant of 1 minus z plus c. And the integral of 3, the quantity of 3 minus 4w times the quantity of 4w squared minus 6w plus 7 raised to 10 with respect to w. So let u be the 4w squared minus 6w plus 7, and the du, derivative u, is 8w minus 6, and our dw is du over 8w minus 6. So 3 minus 4w times u raised to 10w over 8w minus 6. So next is 3 minus 4w over 8w minus 6 times u raised to 10 du, and we factor out this the denominator. So the integral of 3 minus 4w 2 times negative 2 times 4 times negative 4w plus 3, and u raised to 10 du. So so 1/2, a negative 1/2 integral of u raised to 10 du, and apply the integration rule. So negative 1/2 u raised to 10 plus 1 plus c, and yeah, so it will become 1 over a negative 1 over 22 u 11 plus c, and substitute the u, so equals negative 22 times the quantity of 4w squared minus 6w plus 7 raised to 11 plus c, and this is our final answer. The negative 1 over 22 times 4w squared minus 6w plus 7 raised to 10 raised to 11 plus c.